Okay, we are back at three-dimensional geometry, so we're talking about prisms. So we're going to be using a lot of what we had in the previous section to help us figure out what we're asked here, whether it be an angle or a measurement. Couple things, don't forget tomorrow, your what's happening. Okay, the exam, it's going to be right triangle trig, law of sines, law of cosines. Um, shouldn't be too difficult. I put a couple of word problems on there, but mostly it's just basically skills practice. Just remembering, the formulas, substitution, being able to find that material. And I'm hopeful that by the end of the week we should be able to finish up with this, and we'll start calculus on Monday. And I want to say, what are we, 6 weeks away from the paper exams? So we have a good amount of time. I'm hoping 2-3 weeks we get the calculus done. We spend the rest of the time looking at review, and that's what we do the rest of the time. Okay, so let's see here. We finished up number one. Okay, so we're on, it's called a cuboid. I would have called that a rectangular prism. But it says A, B, C, D, E, F, G, H. Okay, is our cuboid here. So we know the length of AB is 12 centimeters. Okay, 12. BE is going to be 10. Okay, and BC is 4.5. Okay, so BC is 4.5. So the height here, 4.5. Okay, we went ahead and labeled the diagram. So it looks like we got 5 parts here. So calculate the length of AE. Okay, and one thing I would encourage, especially, because this is a spatial problem, we're talking about a three-dimensional object. I always recommend drawing two-dimensional objects to represent what it is that you're trying to find. I mean, imagine that this here was a room, so what we're looking for is the diagonal of the floor. Maybe it's another way to kind of represent that, kind of help you see, in your mind's eye what's happening here. But I want the length of AE. So I'm going to go ahead and draw a triangle with the vertices A, B, and then E right there. We already know that AB is 12, okay? We know that BE is 10, okay? And this is just a simple Pythagorean theorem. I mean, what was the Pythagorean theorem? There you go. A squared plus B squared is equal to C squared. So let's just say that X represents that hypotenuse we're looking for, the diagonal. So this would be X squared is equal to 12 squared plus 10 squared. And how do I get an X from X squared? Square root. There we go. So basically I'm looking for the square root of 144 plus 100. Square root of 144 plus 100, or you can go ahead and say, 244. Okay. Well, I'd say we're looking at about 15.6 centimeters. Okay. Would everybody agree? 15.6? Okay, good. So let's say, I'll go ahead and put AE. That's about 15.6 centimeters. Okay. Bless you. Okay, so we got A done. Now it says calculate the length of AC. So if we're still imagining this rectangular prism as a room, well, then we're looking at the front wall. In fact, I would go ahead and probably draw another right triangle. Okay, this would be A, this would be B, but this top one here would be what? Top vertex would be C because we're looking for that diagonal. Okay, so the diagonal on the front wall. Well, we know this is 12, but what's the height? CB is 4.5. Okay, so we're doing the exact same thing we did just a moment ago, but now it's just for another diagonal. So I don't want to go ahead and use the same variable because I don't want to insinuate that these are the same. So let's go ahead and call that y this time. And it really doesn't matter whatever you call it. So this would be y squared is equal to 12 squared plus 4.5 squared. Oops. Hey, okay. There you go, sir. All right. And then in order to find y, once again, we'll take the square root. So let's see what we've got here. So it's 12 squared, 144 once again, plus 4.5 squared. Don't know what that is off the top of my head. So what am I going to get for the length of the diagonal when I push enter? Okay, 12.8 centimeters. Good. All right. So AC, 12.8 centimeters. Perfect. Easy, easy, easy. Okay, now we're going to calculate something a little different. It says calculate the length of BG. Okay, so BG would be a diagonal of the prism itself, not a face. Okay. So what I would probably do here, because it's cutting straight through the middle of the prism, I would go ahead and draw another two-dimensional figure, a triangle, but I would go ahead and use the diagonal, of course, that we're trying to find, the diagonal of one of the walls, and then this base edge right here. Oh, sorry. Okay. So I'd go ahead and probably start with this one, but there's one other thing you're going to notice. So let me go ahead and draw this. Okay. So this would be AGB. Okay, so we're trying to figure out what BG is. Let's call that Z for right now. We know that AB is 12, but do we know AG? We don't know AG. So why don't I go ahead and draw a second figure? Oh, yes, ma'am.
We could put a triangle on this face right here.
The face at the front?
Yeah.
Oh, yeah. So BH should be equivalent to AG, right? Yeah, okay. In fact, my next idea was going to be to go ahead and draw a square, okay, to represent this back wall over here, ADGF. But she's absolutely right. These opposite faces are going to be congruent, so you could use BCHE. BCHE. All right. So that diagonal there, BH, should be congruent to AG. Is everybody okay with that? Okay. Well, let's see here. We know that the height, like BC, is going to be 4.5 centimeters, and we know that BE was equal to 10. Okay. All right. Now it's a rectangle, so I know that's 10. I know that's going to be 4.5. So we'll use the Pythagorean theorem to go ahead and find the length of this diagonal. And somebody give me a letter here. What do we want to call it? We've already used X, Y, and Z. Or, I mean, you really could even use the length itself. You could go ahead and say segment BH squared is equal to 10 squared plus 4.5 squared if you didn't want to use a variable. Okay. All right. So let's see what I'm getting here. Square root of 100, that's the 10 squared plus the 4.5 squared. So I'm getting for that one, let's say 10.96. Now, because it's 10.9, we could probably go ahead and make the argument that the length of BH is just 11. So I'm going to go ahead and put 11 in my figure, but then I'm going to make sure to use that decimal value when I go ahead and calculate the diagonal, the one that I'm actually looking for, just so it's more accurate. Eli?
I know we're triangling on a different structure, but could we also make a triangle using GF and B?
GF and D.
GF and B.
Oh, GF and B.
Yeah, could we make a triangle using that? We could just use, do you mind if I come up and draw?
Oh, absolutely. Yeah, you could do that too. Yeah.
And we already have values for GF.
Yeah, that's right. You could do that. And it should actually come out to be the exact same. Perfect. Perfect. I like when we see these different ways to do the same thing. Good. Very good. Okay. So I know that this height here, because BH is about 11, I know this is about 11. Now I can go ahead and calculate that length. What are we looking for here? BG. All right. So Z squared would equal about 11 squared plus 12 squared. Take the square root of that. And let's see here. So I'm going to go ahead and put a parentheses, and I'm going to use the previous value squared, okay, instead of the 11 that I'm putting on my paper, plus it was 12 squared, correct? 144. Okay, so what should I be getting for the diagonal I want? Okay. 16.2, 16.3, so, okay. All right. So I'm getting Z, about 16.3 centimeters. Good. Good, good, good. Okay. And really it just depends on your perspective. You know, when I started working the problems, the first thing I saw was the triangle on the front face, just rotated down, and you saw the one going straight through the middle of the prism. That's great. That's fantastic. Okay. And D. Let me go ahead and remove this over here so I can actually have some work. It says let M be the midpoint of CH. Okay, so let me come back up here to my diagram. I'm going to put M right there. And then it says R is going to be the midpoint of GH. Okay, so R would be right there. And then it says calculate the length of MR. Okay, so this one right here. Okay, so ideas. How can I find that length MR?
Can we just make a mini triangle?
Yeah, okay. So let's go ahead and make a mini triangle. So I'm thinking you're looking about the triangle MHR. Okay. Well, what would the base MH be?
5.
That would be 5. Remember, it's the midpoint of CH, which is going to be congruent to BE. So this is 5. And do we know RH?
Yes.
Should be 6. Okay. There we go. And let's say MR, let's go ahead and use MR itself. So the segment MR squared should equal 5 squared plus 6 squared. Again, Pythagorean theorem over and over again. So it looks like 25 plus 36. 25 plus 36. What am I looking at? Yeah, 7.8. Okay, perfect. All right, and we've got one more, and we're done with this particular problem right here. Calculate the length of MA. Okay. So let's see here. I'll do this in a different color. So I want to go M to A right here. Okay. All right, so ideas.
Can we make another triangle again?
Which triangle are you talking about?
So can we do MA and then make the mid and then make the like the third like corner I guess be the midpoint of BE?
The third. So you want this one? Okay, I see what you mean right here. So let's call that another letter. Well, what one haven't we used yet? Let's say we use F. How about, what's that? T. Okay, let's call that T. So we're going to go ahead and connect this and then this right here. Okay. I'd say that's a really good idea. Now, we're trying to find AM. Do we know MT? Yeah, that's going to be 4.5. And do we know AT? No, but we easily could figure that out based on another triangle. Okay, so let me go ahead and draw the main triangle right here. All right, so we have ATM. Is that who said T? Is that why you chose T? You just wanted T? There you go. Okay. So let's see. Well, we already know that MT is going to be 4.5. Okay. We don't know what AT is, so I'm going to go ahead and draw. Let me use another color here just to kind of show this. We're going to go ahead and draw triangle ATB right on the floor of this prism. So I know it's kind of hard to visualize, but this one right here is going to be ATB. Okay. Now, we already know that AB is 12. Okay. We know that TB is what? 5, because it's going to be the midpoint of BE. So this one's 5 right here. And this one actually works out nicely because this is a triple. So we don't have to use the Pythagorean theorem unless anybody wants me to. It's a 5, 12, 13. There we go. So now I can come back over here and say, okay, AT is 13. And now we have enough information to go ahead and figure out what AM is. Is everybody okay with what we've done? Okay. So let's see here. Let me go ahead and say AM. That segment squared is equal to 13 squared plus 4.5 squared. Once again, take the square root. Let me go ahead and get rid of all this other stuff. It's not letting me do it because I touched the other color. Let me use my mouse here. Okay, so we have document B, square root, 13 squared was 169 plus, what was it, 4.5? 4.5 squared. What should I be getting for the length of AM? 13.8. Perfect. There we go. I like these types of problems. Don't you think they're fun?
I do because it's not like, oh,
Well, I didn't say anything. Someone over there said it.
like we're given like concrete numbers to each work it.
Mhm.
So like part a challenge for each side.
Kind of a little puzzle to figure out what sides are going to help you.
Yeah.
Okay.
Where like
Yeah.
they just go letters in.
Yeah.
Once they mix the alphabet and math,
Yeah, there you go. But it does help you get in shape. Shape. Ah, she gets it. Okay. She doesn't want it, but she gets it. Okay. All right, next up. Sorry about that. Okay. Number 3. Triangle ABC rests on a horizontal plane with a third point X vertically above the point B. Find the length of CX. So I want this one right here. Okay. Would you like to maybe try this one on your own? There's only one length we're finding in this problem, CX. Okay. Would you like me to give you a little bit of time to look it over? Or does someone already have an idea? They want to come on up? That's what I'm hoping for ultimately, is to get somebody up here to share what they got. But let's say 2 minutes. Let's see if we can figure out what the length of that is in 2 minutes.
it's the angle CBX. Is that a right angle?
CBX?
Yeah.
Yes, that is a right angle.
So it's right angle.
Mm-hmm. Yes. Let me pass back a few other. Oh, that's 8th period. Pass back. Hillary. Hillary. Stop. Okay. So you may not be done, and that's okay. But hopefully you've at least started. You've got some kind of idea as to how to figure out what the length is. Anybody want to show us what you've done so far? Eli? Okay. Sure. Okay, so we see from the diagram it doesn't look like it, but we know AXB and CXB are both right triangles.
Yeah, so actually what I did is I noticed that this was 30 degrees and this was 90, so this means angle X had to be 60 degrees. And that makes this like a 30.
So you're talking about AXB?
Yes, AX.
Okay.
Yeah, AXB is 60 degrees. This makes this a 30, 60, 90 triangle. So that means that XB right here is 15 centimeters.
Okay.
No, it's not squared. And then all I did is then I just used the Pythagorean theorem, knowing that XB was 15 and BC was 20, to figure out what XC was. And I got 25 centimeters.
There you go. I mean, that is correct. All right. Does anybody want me to elaborate? Okay. So here's what he did. He noticed that triangle AXB, and let me go ahead and recreate this right here. So here's AXB, and what we know so far is that this is a 30-degree angle. We know this is 30 centimeters. Now it is a right triangle, but he noticed that if this is 30, this one has to be 60, and see, that's a special right triangle. Do you guys remember the relationship between the sides of a 30, 60, 90? The shortest side is across from what measure? Okay, so this would be X. Okay, what's the length of the hypotenuse with respect to the shorter leg? It's always double the shorter leg, so that's 2x. And then the longer leg with respect to the shorter leg is x squared root of 3. Not that we need that for this problem, but what he noticed was, yeah, if this is 30, but it also represents 2x, well, that's how he was able to get 15. He said 2x is equal to 30, so that x equals 15. Even if you're having trouble seeing that from the special right triangle's point of view, you could just set up a trig function. What trig function uses opposite hypotenuse? Sine. So you could say sine of 30 degrees is equal to x over 30. And then solving it is still going to give you x equals 15. So now he's on triangle CXB. Okay, so let me draw this one right here. Okay, so CXB. Well, he found the height to be 15 from the previous one. We know that this is 20 centimeters right here. And then in order to find CX, he just used the Pythagorean theorem. Okay, so CX squared is equal to 20 squared plus 15 squared. Okay, take the square root. And then that ultimately gave him the 25 centimeters that we were looking for. Okay, good. How many people got that one right? Good, 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 good. And if you're not raising your hand, is there something I can do? Can I help you out? Okay, we got one left. And this is a rectangular pyramid. Okay, so the right pyramid, ABCDV, has its rectangular base ABCD on a horizontal plane and its vertex V vertically above ABCD with AV equal to BV equal to CV equal to DV. Okay, using the given dimensions. So let's see, the base is going to be 9 by 18 centimeters, and looks like those edges are 15 centimeters as well. Okay, find the angle between face ABV and the base. Okay, so in order to kind of visualize this, remember a plane is a flat two-dimensional surface that's going to go forever in every direction. So imagine if this were something in front of me, an actual object. I'm looking at the front face right here. I want to know the measure between that face and the base that we have. So I'm already thinking about a triangle, okay, going straight down here, connecting it here, and then going up along the edge of that face. So this is what we're looking for right here. Does that make sense? Okay, so maybe to go ahead and make this a little more concrete, maybe we go ahead and call this point E. Maybe we call the very center of the base F. Okay, just so we know exactly what it is we're talking about. So I'm looking at triangle, okay, EFV. So there's EFV. So this right triangle is contained entirely within this prism. Okay. Well, do we know anything about this triangle so far? There is one side that we know. Do we know EV, EF, or VF? Right away without doing any work. We know EF because this right here, shouldn't that be half of the side? So it should be 9. Okay, we know that's 9 centimeters. Now, EV, you remember from geometry, what kind of height do we call that? Starts with an S. That's our slant height. There we go. So let me go ahead and draw this face right here, this ABV. There we go. So ABV. Okay. So this right here. So let's say that's E right here. That's supposed to be an E. Okay, so EV represents the slant height. So we know that this is 15. We know that this is 15. Now, if we're going to go ahead and say that E is the midpoint, what's AE? That would be 4.5. So this is 4.5. This is 4.5. And see, that would be two right triangles. So see, I can go ahead and work backwards. I can go ahead and figure out what the slant height is, VE, put that over here, and then I can go ahead and use trig to figure out what the angle is between the face, ABV, and the base of the pyramid. Does everybody see where I'm going with it? Okay. Any questions about the game plan? No? Okay. So let's see here. Let's go ahead and say VE squared is equal to 4.5 squared. Oh, what am I doing? I got used to what we were doing on the previous ones. This time VE, it's not the hypotenuse, it's a leg. So excuse me for 1 second. VE squared plus 4.5 squared is equal to 15 squared. So in order to solve for VE squared, we have to take the difference. Okay, is equal to 15 squared minus 4.5 squared. And then just like all the other times, okay, to find VE, we want to go ahead and take the square root of that. Okay, and what is, I'm just kind of curious, 15 squared off the top of your head? 225, okay. And it's still not allowing me to use that software, so I'm going to come on over here. So I've got control divide. I'm just going to go ahead and put in 225 minus the 4.5 squared. So what's the slant height? About 14.3. Okay. Would everybody agree? Okay. So about 14.3 centimeters. And now that I have the slant height, I can go ahead and figure out what that angle is. So what two sides do I have with respect to theta? We definitely have the hypotenuse, but what's the other one? We have the adjacent. So what trig function am I thinking? Oh, not tangent. Cosine. There we go. I'm going to say cosine of that angle I'm looking for is equal to the adjacent over the 14.3. And what am I going to have to do to find the angle? Got to take the inverse. Okay. So cosine inverse of 9 over 14.3 should give me theta. Now you'll notice, even though I'm just writing 14.3 on the paper, I'm going to use that full value in the calculator. So let me come on over here. Okay, so I want cosine. Whoop, before I do that, let me go ahead and take 9. I'm going to divide by that to make sure I get it. Okay, so now I'm going to take cosine inverse of that because there's my ratio. Okay, so cosine inverse of that. Okay, somebody want to help me out? What should I be getting? $51-ish? Okay. What do you guys think? Okay. Oh, yeah, just put it in there, sir. Okay. Thank you, thank you, thank you. So about 51.02, so we can go ahead and say 51 degrees. All right. How are we doing? Okay. Uh-huh. So let's see. Theta is about 51 degrees. Okay. Questions? Anybody having a hard time? Remember in the good old days? There you go. Okay. Well, we've only got 2 problems left, and we are done. So let's see what they are. So for B, I want to find the angle between the edge AV and the base. Okay. So let's see if I can go ahead and do this on here. So we want it between AV and the base. So for this one right here, I would probably go ahead and draw another segment where to kind of illustrate the angle that I'm looking for exactly. Okay. So remember, we're calling this was E, correct? And this was F, or was it vice versa? Okay. So I would probably connect A to what? I connect A to E, and then I'd be looking at this guy right here. So this is the angle that I want. Again, another right triangle completely contained within the prism. Is everybody okay with that? Okay. Now, let's take a look at C as well. It says the angle between the plane ABV, okay, so this front face, and the plane DCV, so the back face. So basically, this angle right here. If I were looking at it sideways, the angle created between those two planes. Now, I'll be honest, I've never seen a problem like that before. So this one, that one's kind of tricky. So here's what I'd like for us to do. We have a decent amount of time left. I want you to go ahead and try to calculate both B and C. Okay, working together, using your notes, whatever is necessary. Take the rest of the time to go ahead and get those answers, and then on Friday, when we finish this up, we'll come in, we'll take care of the homework on the 2D geometry. Then we'll have some folks come on up, show me these problems here, and then you'll have the rest of the time to go ahead and work on your assignment for the 3D geometry. Okay, sound like a plan? Okay. All right, so I'm going to go ahead and turn you guys loose. Okay, if you think you have it right and you want to check with me, let me know. All right.